Hi guys, welcome to the video for recommendation system. So guys, today we'll be building an end-to-end data science project that would be mainly consisting of recommendation system. So guys, let me start by giving you an intro of what we are going to do and how the lecture is going to be phased out. So the first thing that we are going to do is understand what is recommendation system, and then we are going to first see the demo of what we are going to build. So guys, recommendation system is nothing but it's an engine that recommends stuff. So guys, you must have seen, it's a very common example is in Netflix you get recommendations, right? And then based of those recommendations you tend to decide that whether you are going to watch that particular film or not, and related stuff guys, right? In e-commerce also we get a lot of recommendations. In quick commerce also we get recommendations, right? That let's say someone is ended up buying bread, so it is very likely that they might order butter as well, sauce as well, and a lot of stuff guys. So basically recommending stuff to users is known as recommendation system, and we need to build out the back end of recommendation system today, and that's why we are here. So the approach that we will be using it here would be collaborative filtering collaborative filtering. So we'll be using this approach, and guys, I'll be explaining you everything in depth, so don't worry. And now let's just move to the demo of what we are going to build. So let me just play the demo. So this is the demo. So let's say what's going to happen is that let's say uh, we are going to enter the user ID as 9, and then we are going to press enter. So based on what films user 9 has seen, so this is the set of films which a user 9 has seen. We will click on this button and we'll get the recommendations. Okay, so our project essentially what it does is that we ask the user we ask the user we ask the user to enter user ID, and then based out of that we see the history. So what does history consists of? History consists of the fact that how many and which films the user has seen. Okay, so based on what user has seen, that's essentially its history, recommend we will recommend him films. That's the simple goal of the application that we will be building up. So this would be the high level workflow of the application. Now let's try to understand how we would proceed ahead and what are the things you need to know. First of all guys, in the GitHub, in the description section you will find the GitHub link for the video. Everything is documented there, so start you can start using it. Okay, now the thing is what I have done is that apart from collaborative filtering, apart from collaborative filtering, I am also leveraging LLMs. Okay, so what essentially I am following is, first of all, this approach is inspired by Nvidia's. So Nvidia is a company, as you all know, it's one of the world's most valuable company as of now. It had a research paper. It had a research paper, and the name of that research paper was Lamarck. So I have taken inspiration from this research paper, and From this research paper only, I have built a simpler version of this. Okay, now the thing is, how is this going to work like? So how this is going to work like is that there are two essential steps in the project. One step is retrieval, and the next step is LLMs, and then the third is nothing but third is simply just you can ignore the third step, it's fine. So there are two steps, one is retrieval and one is LLM. So guys, see, you can say that let's do one thing. Let's, this is the history of the user. Let's pass the entire history to the LLM and ask it to recommend relevant films. That could be one approach. But guys, the a problem with that approach is one, it's very expensive. Okay, since let's say a user has watched 100 films, so you would pass those 100 films, then it would take time understand those 100 films, then recommend. There would be a lot of stuff which is not in your hand, right? So you wouldn't want it to be that way, and the thing is that the biggest thing is time consuming, right? So LLMs are great, but what exactly happens in at the core of it is that the LLMs which we use have a property like their task is next token prediction. So they are essentially trained to predict the next token. Okay, so token wise the output will come, and this would be slow. So this is why first of all we need a retrieval. What would retrieval do? This retrieval, this would, it more like that, hey, this is the history of the user, you don't have to rate it from all the films which are there in our database, just give us from a few set of films. So this is basically what will retrieval do is that retriever is a thing that we have implemented. This will select the best candidates. So those best candidates along with the history. So what is history over here? History is the set of films which user has watched, and then we have implemented a retriever which would essentially give us the best candidates, and history plus best candidates would be then sent to an LLM. Okay, once they are sent to an LLM, post that LLM would generate an output. It would generate an output in a particular format, and then we'll parse that format and get the stuff done, and then show the recommendations. So I hope the architecture is clear. It's not very difficult. It's more towards breaking down the problem into two steps. One is, in one step we are uh, having a retriever which will give us the best candidates. Those best candidates plus the history. What are best candidates? So best candidates are the set of films which are likely to be loved by the user based on its history. But for final ranking and for final prediction, we'll be using an LLM. So which LLM I have used? I have used Claude's Haiku model. This is the cheapest and fastest model for cheapest and fastest model by Anthropic. If you want to use any other LLM, guys, it is very simple to do it. You can change it to OpenAI's any model. You can change it to Gemini as well. And even guys, you can use Llama models as well. So in the original paper, they had used Llama models, but there was some other reason as well for going for a open source LLM. We won't go into that, but yeah, the architecture was little different. They were what they were doing was even more efficient than what we are doing. So I think yeah, that's pretty much it on the introduction part of it. Let me go to Claude. So guys, let me just go to Claude, and so I wanted to show you one set of difference which was there. Let me see if I can pull in that chart. I had published an article, not article exactly, an artifact that would really give you that thing. And yeah, let me just see if I can search it. Okay, so I'm not able to find it yet. Let me see if it's there. Yeah, it's not there. Let me see if it's here. Okay, let me go to my history. So ah, let me see if this works. Okay, no, this is not there. So I wanted to show you something. Wait, allow me a couple of minutes to search it. Let me, yeah, let me just allow me 1 minute to just search it. I'll just search it. So guys, yeah, so this was something I was searching for. So let me just put it down. So see guys, the main thing that we are doing over here is that we have a two-stage approach. Even the original paper from which I'm taking recommendation has a two-step approach. Then it's retrieval followed by ranking. Even they had retrieval followed by ranking. So that's on the architecture side of things. Then guys, essentially for retrieval, the main thing is that once based on the user history, I need to pass my LLM some best candidates. What does best candidates mean is set of films which are more likely to be liked by the user so that the LLM can process less information and give output in a more efficient way and a better and more quick way as well. Okay, so for that purpose they have used LRU, a sequential recommender, but I am using collaborative filtering. Okay, and then yeah, that's essentially it. Everything we'll see later on. And then on the ranking stage guys, they are doing it via llama 2 because they want to have they are not exactly generating the output in a token by token way. They are doing it some other way, but for the time being we have used Claude for ranking. And yeah, that's pretty much it. So we have used Claude, that's okay. Then guys, that rest all is okay. Rest all you will understand step by step only. Let me still try to give you a final glimpse of what is the thing. So the main thing is that the main workflow for now that you need to understand is two-step process for recommendation. One is best candidates, and this is done using collaborative filtering. Okay, specifically we have done item item to item based collaborative filtering, and then this method helps us give the okay sorry this method essentially gives us the best candidates or the best set of solutions, and then this best set of solutions combined with the history of the user. That means what is the history of the user, essentially the films that he has watched in the past. And what is the best set of solution means, best set of solution means that what is the best possible outcome or the best possible recommendations. Both of them are sent to an LLM, and after that we get an output. Okay, obviously we are doing some parsing and all that we'll cover later on in the code. So I think the application workflow is clear, the demo is clear, and everything is clear. Now let's move to the code part of it. So guys, whenever you see some code, so at times it might feel little overwhelming, but don't worry guys, it's not a very difficult base code. It's just you need to spend some time and understand it. And yeah, so let's just try to spend some time and try to understand what we are doing. And obviously guys, I have implemented it. I'll be giving you full in-depth knowledge of everything, theory plus code. So guys, we'll leave this part. Okay, this is just a module import and all, and this is just page config, and this we are just setting up some styling properties using some custom CSS code. It's okay, you can skip it. Then guys, we are setting the API key for Claude. I think that's okay. You must have seen that. That's not a big thing, right? Because we'll be anyhow using an LLM. So later on, if anything comes, I'll explain. So guys, let's start from the first step. So guys, the first step for any data science project is this only, that you must have some data and you need to write code to extract that data, right? Wherever that data is lying, so you need to write code to extract the data. That's what we are doing over here. So if you will see that in my data folder inside ml100, so data ml100, that's the path, there are multiple data sets. Okay, now what I'm doing is I'm reading, okay, I'm reading this plus u dot data. So if you'll click on u dot data, obviously everything is there. So in u dot data you have columns such as user id, item id, rating and timestamp. So this user id has rated this item a movie rating of 3 in this timestamp. That's what the data is. I hope it's clear. Okay guys, I'll be covering everything line by line. And the separator here is tab. Okay, then we have one more data set, that's essentially our movie one. So let me see. So it's u dot item. So if you'll go to u dot item, you will find that we have a movie data set, and in which the tab, the separator is this pipe symbol. So that's what it is mentioned over here. And these are the columns guys. Okay, movie name and the release date, video release date, and everything is there. Okay, now what we are doing is we are reading the movies data set, we are reading the items data set, that's basically the ratings data set, and then we are merging it, and then we are converting the timestamp to date time, and then we are sorting it. So guys, these are normal operations, I think you can understand it, but let me still try to give you a complete glimpse of what we are doing. So see guys, what we are doing essentially is, let me just see if I can have both the windows parallelly open, because this is exactly half screen only. This, if we close, so yeah, this is it. If we can have both screens open parallelly, it would be great. Let me see. Since I've switched to cursor, so I just need to figure out how do we get this thing closed. So for some reason this is not getting closed. hmm okay, that's not a big thing, we'll just move it here, and then we'll write over here, and then we'll understand it. So guys, in the data loading stage, okay, everything I'll be explaining you in the, okay, let me just take a different pencil. Yeah, so in the data loading stage, we have a data directory, and from that directory I'm essentially extracting two sets of data. One set of data is u dot data, okay, it's mentioned over here, u dot data, you can understand this, and one is u dot item. So what does u dot item have? It is essentially the data where you have item ID. What is the item ID? What is the title of the film? What is the release date? What is the video release date? What is the IMDb URL and stuff? Okay, and to which genre it belongs to. Okay, for the time being we are not using genre and all, but still, yeah. In the item data set, you got the information that you have movie level information. And in this thing in u dot data you have rating level information. Okay, rating level information, if you will see u dot data, you would find out you have columns such as user id, item id, rating and timestamp. What does that mean? Which user id has rated what item with what rating in under what timestamp. Okay, this is clear guys, I hope. Yeah, then what we are doing is we are merging on what item id. So what does merging means? So we are merging. So guys, if you have followed along my Python playlist, I have covered it, but yeah, merging essentially means that we are applying a join. Okay, so here I think we are Yeah, so essentially it's not mentioned, but yeah, what we are doing is we are joining u dot data and u dot item. On what item we are, on what column we are joining is item id. Okay, if you will see here, I have written on item id. So what is happening is that inside my data set, let me show you. Inside my data set, after this join operation, what columns will be there? Tell me, guys. You will first have, since you are having ratings on the left side, you will be having user id. What does user id means? User id means which is the user involved. What is the item id? This is the joining column as well. What is the item id of the film? What is the rating given to the film by the user? At what time did he give that rating? And then you have title. From where we got title? We got title in this data set. Okay, this is the data set that has movie title name. So that is the reason, because I wanted title column in my data set, I had to perform a join operation. That is why I'm using merge. I hope guys this is clear. And then I'm converting timestamp to normal date format, and then I'm just sorting the data set by user id and timestamp. That is okay. And then guys, what I'm doing is I'm creating user history. Okay, let's just try to see this. What does user history mean? So if I let me try to close this thing. Let me try to close the compiler, and let me go to the. So guys, for every section I have broken down the code so that you can really understand it very well, because sometimes just seeing the entire code might feel scary. So we have broken down everything so that you can visualize it even at a much better layer, that what is user history. So let's just try to run it. So cd src py data loader dot py. Okay, strange, no module named pandas. Okay, that's strange. So cd pip install -r requirements.txt. So guys, not sure, for some reason the libraries weren't installed, so yeah, let it get installed. So guys, it will take some time. Let's just meanwhile talk only. So guys, the thing that we are doing here is we are writing the data loader package, and we want to have a data set which have these five columns. User id, essentially what is the id of the user? What is the item id? So what is the item id of the film? Then we have rating. What does rating mean? Is essentially what is the rating given to the film by the user. And then we have time, at what timestamp he is going to do that. And then we have title. So what does title mean? Essentially the title of the film. So let's just see, for instance, here you had, right, see this app. So this is the title of the film: Koila, Ghost, Gandhi, Star Wars, and then you would have recommendations coming up. Let's just see that is our environment ready. Okay, it's still getting ready. It takes some time, guys. So yeah guys, so what I was telling you is that I have broken down the code for each section so that you can understand each section in a separate code base, not code base, in separate file, so that in case it's the entire code is overwhelming, you can take one step at a time. Like for the time being, we have taken data loading right now, so we are understanding that how we had to data set, how we read them, and then how we are joining them on a particular column, and then we have a combined data set, and then we need to understand that what is user history. It's not very difficult guys, user history is very easy. Once you will see the output, I'll explain you, you will understand everything. That's my promise. but the problem is that it takes times to set up the libraries and everything. So let me just pause the video until then. So guys, yes, now the packages and everything got installed. It took some time, that's okay. So now let me run py data loader. Let me see if it runs now. Data loader dot py. Okay, let me go inside the src directory. Now let me try running it. So guys, everything got successfully run. So guys, before I explain you the code, I have explained you the code. I'll explain you everything. Just try to always remember that whenever you're doing a data science project, always have a separate structure for data loading. Okay, right now we had two tables, we joined them into a single table. That is relatively simple operation, but if you have a lot of tables, a lot of complex db structure, so you would want this code base to be separated, right? So it's better to write your code always in classes and functions, so that the usability increases and it really becomes easy for you to debug as well. So let's just go and understand what happened. So see guys, first of all we have user item id, rating and timestamp. So let me just get this thing here, let me get this thing over here. Yeah. So you're able to see that now I have a data set. What does this data set have? It has user id, it has item id, it has rating, it has timestamp, and it has title. So how I was able to get this? I was able to get this because there were two data sets, and I joined them. On what column I joined them? Item id, and one specifically the ones for item had a column called title. That's exactly your movie title. And now I have that in the final view, which I'll be using, final view or final data set, that I'll be using for further analysis. Okay, and guys, the data is simple. That what is the user id? That means which user. Item id, this is the idea that what item id this title is associated to, what is the rating the user has given, and what is the timestamp. If you see, we did convert the timestamp into the format it is required to. So I have written code for that as well. See, we are just converting it into a timestamp base so that Python can read it simply. Now what is user history? So see, what is user history? Just try to see the structure of this thing and then I'll explain you what is user history. So it's a dictionary one, and it has values separated by comma, 172, 165 and so on. Let me explain you in the board what it is. Even if you will see it, some of you might be able to make sense out of it. This is user id 1 has rated item id 168, item id 172, item id 165. So user 1 has rated 168, 172 and 165, and similarly you have data set like for example you might have second user has rated 100, 200 and so on. So what does this mean? This means that the second user has rated item id 100, second user has rated item id 200. That means what are item ids, guys? It's nothing, it's just titles of movies, right? So for every particular movie title I have a corresponding item id, right? Like we have id, a department table, right? What is the id of the department and what is the department name? So in simple terms it's the same thing, that for every title you have the particular item id. So I think user history is also clear. It's just the a dictionary of, let's say, user id 1 of what set of items he has reviewed. Okay, that's good. So now we are able to understand the data loading phase. So some of you might say that why do we need these columns? So everything, guys, you'll understand slowly, but let's just try to stay along and try to understand this, that what are we trying to do over here. Now guys, we are creating a user item matrix and we are doing pivot, and then we are doing user to index and item to index. So let me try to understand that what is this set doing. Okay, let me just try to take some, I'll explain you guys. Let me write this three things: user, item, data frame, and there is some pivot and all, right? Don't be scared guys, it's very normal operation only, and we have user to index as well, and then we have item to index as well. So don't worry guys, these are very simple things. At first these might look little complex, but trust me, these are very simple things. And in case any Python related doubt is there guys, just go through my Python playlist. About 18 questions are uploaded, everything would become crystal clear. And please guys, subscribe. So now let me just explain you what are we doing over here. So what is this user item df, and there is a pivot thing that's going on over here. So guys, see what exactly we are trying to do is that I want to have a user item data frame which would have this structure. So the structure would be similar to what a spreadsheet is. So you have user ID and then you have item ID. So let's say user ID 1, 2, 3 and item ID 1, 2 and 3. And what is there in the middle part of it? This is like a matrix, okay? What is there in the middle part of it? In the middle part of it, you will have rating 5, 4, 3, 5, 4, 2, 4, 4, 5. What does this mean? Is user ID 1 has rated item ID 1 with the rating 5. In business sense, this would be more like, let's say user name is Aditya and he has seen films like Jawan, Pathan, Fighter. So all three are action films. And let's say I love action, so 4, 4 and 5. So what I'm trying to do, I'm trying to just establish that this pivot table exactly means this in business sense. Okay, I hope this step is exactly clear. I hope no doubt is there. That is what in the code is user item data frame. It's this type of data frame where you are exactly storing the user items and the corresponding item IDs. What are user IDs? Simple guys. IDs assigned to the users. And what are item IDs? Item IDs are IDs assigned to movie titles. And what are your movie titles? Your movie titles are simple guys. In the database obviously you won't have Jawan, Pathan, Fighter, but example. Now this is done. Now you are asking what is user to index. So see guys, what is user to index? It's very simple guys. What we are doing in user to index is we are trying to create a mapping of every user, that in our dictionary what index it is at, what index it is at. Okay, this is very important. The question is at what index it is. So the thing is that user 1, let's say user 1 has watched 1, 2 and 3 films, it has rated. So at what index it is? Tell me guys. It is at index 0 because at Python things start with 0, right? So you'll be able to understand these are just intermediate things which we are doing. Same for item to index as well. That I just need to create a mapping, that what is the mapping at an index level, that okay, at 0th index item ID 100 is there, at 1 index item ID 101 is there, because I'll use some things in the end for retrieval operation. That is okay, right? So now that is also done. So see guys how I'm able to make you understand. And we are also filling the null values with 0. So guys, there is a little bit of a catch out there that I want to give you so that you understand this in depth. That what does a null value mean? Let's say there is Aditya, then there is Jawan, there is Pathan, and there is Fighter. And let's just imagine that I'm having 3, 4, 5 stars, and then there is Aman. It has a none value over here, and 4 and 5. So what does a none value means is that Aman hasn't rated Jawan. Okay, and this is the core of the application. Let's say I want to recommend a film to Aman, and if you will see that Aman also likes action films, and he has given very similar rating to what I do. And I have also seen Jawan, and I'm given it a rating of 5, which is higher. So it is very likely, since Aman, which the common films that we both have watched, we have rated them as high, and I have watched an extra film which I have rated as 5 stars. So it is very likely that Aman would also enjoy that film. That's the goal of this application. That's the core behind this application. Okay, so we are good till here. So just understand a none value exactly what does it mean. A none value means that the person has not reviewed the film. Okay, simple guys. Let's move to the other part of it. Now we are computing the cosine similarities. Okay, so I think if you understand this, rest everything is very normal only. It won't take much time. Don't go by the code length, guys. It's just normal code. We'll understand everything. So where are we at exactly? We are at the stage where we need to compute item similarities. Okay. So guys, what matrix do we have? Tell me. So we have a matrix. So let me just write it down. So we have a matrix in which I have okay. So I have a matrix in which I have user ID and I have item ID. So user 1 2 3, item ID 1 2 3, and this is the type of matrix I have, and it's more like the rating, right? 5 4 5 3 4 5 4 4 5. Simple, guys. Now what I need to do is I need to compute cosine similarity. So how I'm going to compute cosine similarity? The underlining idea is that this is the main part of the thing, that the underlining idea is that first of all what we'll do is we'll transpose this matrix. So guys, I hope you understand transpose. So by transpose what will happen is 5 4 5 3 4 5 4 4 5. So guys, it's just that this would become this would become this, and this would become this. I hope you are able to understand it. So we have transposed it. So this is item 1, this is item 2, this is item 3, this is user 1, this is user 2, this is user 3, because we have transformed it. Now what does computing cosine similarity mean? Cosine similarity is used, okay, to compute similarity between films based on user rating. So based on user rating, I am able to compare that how similar two films are. So what will happen is I'll have a matrix. That would be the output of it. It would have the diagonal elements of all the cosine similarity matrix are 1, since the item with itself is always similar. So then you would have A12. What does A12 mean? A12 mean is that what is the similarity of this item. Let's say this is Jawan. Let's say this is Pathan. What is this? What is the similarity which Jawan and Pathan have? Okay. So how we would compute this? So there's a formula for cos theta, that's A dot B, and this is the formula. So we'll do 5 into 3 plus 4 into 4 plus 5 into 5 plus under root of 5 square plus 4 square plus 5 square into 3 square plus 4 square plus 5 square. So if you will do this calculation, let's say this comes out to be 0.9. Now guys, don't tell me that this is not 0.9. I'm just guessing it's 0.9. So let's just write 0.9 over here, and the same number will come here as well, because these things are equal, right? So A21 is equal to A12. So this is how you will compare and compute a matrix. Now what does, let's say you have a matrix which is like 0.9 and 0.9, 1.6, 0.6, 0.8, 0.8 and 1. So what does this mean? This means that the similarity between this matrix means that the similarity, this is the cosine similarity matrix, okay, cosine similarity matrix between your films. Okay, this is the cosine similarity between your films. That means that Jawan and Pathan, what is the cosine similarity between Jawan and Pathan is, it's there in this matrix, okay, because exactly you will have Jawan over here, Pathan over here, and let's say fighter over here, and you have Jawan over here, Pathan over here, and fighter over here. So this is basically that Jawan and Jawan, as I said, that the film with itself will always have the similarity and one, and let's say Jawan and Pathan are related to 0.9, Jawan and fighter are related to 0.6, Pathan and Jawan are related to 0.9, and similarly it happens, right? I hope you are getting it. Now we have even computed the cosine similarity. Now what exactly we are doing in the retrieval stage, okay? So guys, don't get scared. I'll explain you this entire thing at one shot, that what is the thing and how we are doing it and how we are getting motivated to do it. Okay. The thing that we are doing over here is we are retrieving it. What we are retrieving it is, let me explain you with an example of how we are doing it and what is the entire code base doing ahead, so that even if there is some confusion, everything will get clear at one shot only. Now let me restart with the final thing, because every other step is, guys, interlinked. It won't be very difficult for you to understand. Let me take black pencil only. So the thing is, we had movies data, we created a final data set. Okay, I have explained you the things in which I have item ID. Okay, I have user ID. Okay, and then I have title of the film, and what is the rating and what is the timestamp. Okay, I think you are able to understand all these things. Okay, we have done till here. Now I have computed a cosine similarity matrix as well. Cosine similarity matrix as well. What would that mean is that I am computing item level similarity. Why I need item level similarity? Because this item level similarity is based on ratings given by user. So once I have this cosine similarity matrix, I'll be able to get the answers. I will be able to retrieve the answers, retrieve the answers for best candidates. Okay, I need, first of all, if you would remember from the starting, I've been talking about best candidates. So because I have a cosine similarity matrix which computes the similarity between the items based on ratings, then I can do some retrieval operation and get the best candidate. So the best candidates are like, prior to an LLM stage, I need the best candidate. So how I'm doing that? That's the main goal of this code, the next piece of code. Let's just try to read the code line by line, that what it is exactly doing. So guys, the first thing is that if the user is not there in the database, obviously you can't recommend him anything, because we are doing this thing based on user history. Okay. Now we are having user index, history index, average similarities, we are masking, we are sorting, and we are trying to arrange it in the terms we need, and then we are just trying to map our indexes back. So guys, if you will just sit and try to see why I'm using this indexes, it's simple, because in the end I would get everything. Like, it's like a dictionary that I've created, so that everything, the retrieval process becomes quite efficient. So now the thing that I'll be doing is I'll be explaining you that what exactly is happening in the backend with the help of an good example. Okay, let's see, we have two films. You have Jawan, you have Pathan. Okay, you have Fighter, and then you have Jawan, Pathan, and Fighter. So what this code does is, first of all, it sees what films you have seen. What films you have seen. Now let's say you have only seen Jawan and Pathan. You haven't seen Fighter. So the data set would get reduced. You will have Jawan and Pathan. And then you have Jawan, Pathan, and Fighter. So what is the similarity between Jawan Jawan 1, Jawan Pathan 0.9, Pathan Jawan 0.9, Pathan Pathan 1, Fighter Jawan 0.8, Fighter Pathan 0.9. Now you are asking, sir, from where I am getting these numbers? Guys, we are getting these numbers because of cosine similarities which are given by ratings, right? So users have rated this film. Based on that, we are able to compute cosine similarities. Now the next question is that, okay, I haven't seen Fighter, so that is why the dataset removed Fighter. Now what it will do is it will compute the average of it. So Jawan, Pathan, Fighter. So what would be the average of this? Would be So it would be almost like 1 only, but you can imagine it, right? Point, it would be like point this divided by 2. So what is 1.9 divided by 2? It is 912 divided by, so it's approximately 1 only. So let's just write it as 1. This is also 1 and this is less than 1. So what does that mean is, that if a user comes now, if a user comes now, you have computed these similarities. Okay, now let's say you have one more movie called any romantic movie. Let's say you have any romantic movies. Let's say you have Rocky Ki Rani. Okay, point 3, point 6. So this would be less than, let's say this is 0.9, so 0.9 is 0.45. Okay, that's the average. I'm just computing the average. Approximately this is 1, this is 1, this is less than 1, and this is 0.5. Rocky Ki Rani Ki Prem Kahani. Now the next step would be, the code will see and say, okay, the user has watched Jawan and Pathan, so I won't recommend it, because that's what I said, that the user has watched Jawan and Pathan. It will say that, okay, now in my database I have two films, Fighter and Rocky Rani Ki Prem Kahani. Fighter has this one and this has 0.45. So which film it should recommend you? Obviously guys, it would recommend you Fighter. That's the goal this code is doing. Now if you will see the code, that is what we are doing, is that is what we are exactly doing over here, is we are just, see, I told you, right, we are just computing the mean, and then you would be telling me, okay sir, this is okay. And similarly guys, we are just converting everything back to our items only, so that we would use it later on for our, we would use later it for our assessment and efficient retrieval process. Now guys, the last thing is get title. So we are just getting the titles based on item ID. I don't think this is very difficult. Now guys, comes the main part, and how I am using it and how we are closing in on the application. This is very important guys. If you understand properly the theory part of it, the code part is very simple guys, and obviously you have LLMs which can help you understand the part. Now what will this happen is, this will give me the set of best candidates. Now the best candidates along with the history would be combined and sent to an LLM. Once it is sent to an LLM, what will happen is that LLM would be asked to generate an output like A, B, C, D. What it will do is, see, in the prompt, if you will see, the way I'm passing it would be that I'm telling an LLM that, hey, this is the user history and this is the set of candidates movie which is coming from assessment done on cosine similarity level, which is computed using the ratings. Just give me the output in this format. Okay, C, A, B, C, D, D, F, G. These are basically the indexes of the film. So if you will see that, let's say film A is, let me just show you how it will output. Let's say A, it would get the input like this: A is Fighter, B is Rocky Ki Rani Ki Prem Kahani, Rocky Rani Ki Prem Kahani, and it will have my history as well. History would be A Pathan and B Jawan. So it is being asked that, hey, just output this index, because as I said guys, we don't want the LLM to run into a fact that it would generate a long string of responses which is not used for our applications, and that's what was mentioned in the research paper as well. So it would just retrieve A. Why? Because it would retrieve A and B. Anyhow, my ranker won't send Rocky and Rani ki Prem Kahani in the best candidates list. There'll be more set of action films which would be sent, and this would just give me output like A, B, C, D, E, so that I'll have this output in an descending order based on relevance, and then just I'll guys use this A, B, C, D, E, map it back to the titles and just render it. That was the main goal of the indexes part. So if you'll see the code base, you will be able to understand why I'm using the indexes and what is parse strict ranking. So guys, it is nothing based on the LLM output. I'm just parsing it. Okay, parsing it, so that I'll have a proper output, so that I can just get these things and later on we can show. Rest all guys is a simple UI UX, nothing. It's just that user will enter the user input, and based on that the function would render and it would call the LLM and then display the result. So there's nothing magic out there. The code you can understand, and obviously guys, if you have any doubt in the code, no one in the YouTube does that, you can DM me. I have written this code. If you anywhere face any difficulties in understanding the code, just DM me. Now I'll just explain you in the end a good ending part of the video in which you can understand everything at once if you have missed any step guys. See, for some of you the code might be a problem, but code is not the goal. If you'll spend some time, spend around uh, 8 to 12 hours, 8 to 12 of clean hours, you will be able to understand the code. But code understanding is secondary. The main is what I have implemented, what is the application. This is, I would say, an intermediate level project because this requires granular understanding of things. Okay, so let me just tell you that what I have exactly done. So guys, data loading is clear, right? Then I am exactly what I'm doing is then I'm computing similarities between films. On what basis? On the basis of user ratings. Okay, I have a cosine similarity matrix. So I have a cosine similarity matrix given to me. That's good. Now the question is that how is the stuff working? So first of all, I'll see the user history. Based on user history, I'll find out the best candidates. How I'll find out the best candidates? Because of cosine similarity. Once I have the best candidates, these best candidates plus the user history will be sent to an LLM, and it would be asked to just give me the best recommendations in the form of this, like A, B, C, D. Then I would parse them, just extract these A, B, C, Ds and do the mapping back to titles, and then display. Tell me guys, is this difficult? This is very simple guys. See, this is not difficult architecture at all. Data loading is clear. So I have then computed a matrix, cosine similarity matrix based on ratings. Yes, so in the first place you would have to visualize that you have a what does cosine similarity matrix means. Here I have explained you, right? See how Jawan and Jawan are related to 1, how Jawan and Pathan are related to 0.9, right? So that is how cosine similarity matrix are getting computed. Then based on this I am getting the best candidates result, and post best candidate results guys, I am using user history and sending them inside an LLM. I am using Anthropic. You can use any LLM of your choice guys, and then it's rendering me the best results, and then just guys I'm displaying it. Okay, I'm parsing them. Okay, I'm parsing it just to find out what are the titles and everything. You can even simplify the workflow, that's okay. But guys, I hope you're able to understand this. This was the intermediate level project, I would say. So it usually takes some time for beginners to understand this, but guys, this is the bare minimum level of understanding that you should have if you really want to work on a good project, right? This is not a difficult project, I would say, but yes, this requires you to study these things. Right now, the first thing is that you understand this as well. I've shown you. Then maybe some of you might not understand what exactly cosine similarities is. So spend some time, try to understand it. It's not difficult at all. Then some of you will have, for me, implementing the retrieval was little difficult because it involved uh, little bit of logic building. Specifically, like I gave you an example that let's say you have watched Jawan and Pathan. So once the best candidates list will come, it should exclude Jawan and Pathan, right? Because you have already watched it. Then I need to take the average so that I could just have one stack of a matrix which could get sorted in descending order, and based on that I can recommend the best candidates plus the history to my LLM. And then guys, it's simple only. If you would see, the LLM would just output things in this manner, and then I'm parsing it, and then guys I'm just displaying it. Okay, nothing magical is being done over there. So you can spend some time, try to figure out this project, and if you have any doubts guys, just try to DM me directly over my Instagram and LinkedIn. I'll be more than happy to explain you. And I want to give a thought, I want to give a shout out to Nvidia's research team. Based on this research paper only, I got motivated and I implemented this use case. And let me just show you what is their architecture as well. So they are using this architecture, let me just close it. So they are using this architecture. So see, I have user interactions, and then I am having the retrieved candidates. So this is the retriever, this is the retrieved candidates. That means for retriever purposes I am using what I'm using exactly is cosine similarity. So I'm having the set of best candidates, and then guys I'm passing it to an LLM, and then I'm displaying the outputs. Okay, this is, they have used an LLMs and they are ranking it via the logit, so you can skip this step for the time being. Okay, so but guys, in case, please subscribe to my YouTube channel, and if you have any doubts, just DM me. Okay, and also a lot of content is already there, so you can DM me directly also. Thank you guys, and have a great day ahead. Thanks.